Hi guys, today we want to look at writing the equation for an exponential function when we have its graph with maybe only 2 points indicated on the graph. If there's lots of points indicated on the graph, then it's easier to write the equation. For instance, in the first picture here, with every single point with the x value 0, 1, 2, 3, it's easy to find the growth factor and to write your equation. When you have fewer points, like in the second one, and one of those points is not necessarily the y-intercept or the initial value, it can be a little more tricky. So that's what we want to look at today. So the first type we're going to look at is when the y-intercept is indicated on the graph. So we know that every exponential equation is of the form y equals y naught a to the x or t. I'm going to use x this time. Okay, so the first thing we do is this y-intercept here. This y value is our initial value, y naught. So we know that y naught is 1. So if we plug that value into the exponential equation, y equals 1 times a to the x. Do we need to use the 1? No, when it's 1, we know this is just y equals a to the x. Now we need to find a, the growth factor. So the way we do that is we take this other point to 100. If that is a point on the curve, then it works in the equation of the function. And x is the 2, and the 100 is a y value. So we're going to plug that into our y equals a to the x. So y is 100. I still don't know my growth factor, and x is 2. Well, if I know that 100 is a squared, I can square root both sides, and that will tell me that a is 10. Now I know my a, I know my y naught. I can write my equation, y equals 1 times 10 to the x. And there we go. Let's try one more like that. So here's another one. We have the y-intercept. There it is. So our y-intercept, or the initial value, is 1.2. So that means right now our equation is y equals 1.2 times the growth factor a raised to the x. Now we do have the point 2, 4.8 is also on this curve. So I'm going to plug the 4.8 in for y. I don't know my growth factor. And my x is 2. Now I'm going to try to solve this. So in order to solve, I'm going to divide both sides of this equation by 1.2. So that will give me 4 equals a squared. And if I square root both sides, now I know that a is 2. So I know a is 2. I know my y naught is 1.2, so I'm ready to write my equation. Y equals the initial value 1.2 times the growth factor 2 raised to the x. And there we go. Okay, now what if one of the points we have is not the y-intercept? That makes this a little trickier because I don't know I don't know my y-intercept. Now remember, we still know that y equals y naught a to the x. What we do is we take each of the points and we plug them into the equation. Now I'm going to give you a little hint here. If you're not a fan of negative exponents and you don't like fractions, I would start with the point with the bigger x value, the point further to the right. So I'm going to take the point furthest to the right, 8, 5,000. And it really doesn't matter which point you pick first. But like I said, if you don't like fractions or negative exponents, pick the point on the right first. And if we plug this in, 5,000 goes in for y. I don't know y naught. I don't know a. And 8 goes in for x. Now I'm going to take the second point, which is 2,000. And I'm going to plug that in. 2,000 goes in for y. I don't know y naught. I don't know a. But 3 goes in for x. Okay, so now we need to remember that exponentials have common ratios. So what we can do is we can divide these two equations. Remember when we had linear equations and we had two equations with two unknowns, an x and a y? We would add or subtract those two equations, okay, so that we could eliminate one of the variables and solve. Now we have two equations with two unknowns, but they're exponential equations. We divide them, and look what happens to the y naughts. They go away. They cancel out, they divide to 1. And what we have here is 5,000 divided by 2,000. That's 5 halves. If you want to use 2.5, that's fine. And on the other side, 8 to the 8th divided by 8 to the 3rd. We subtract the exponents. 8 minus 3 is 5. Now we have one equation, and we can solve for a. In order to solve for a, we raise this to the reciprocal exponent. So we're going to raise that side to the 1/5, which means I need to raise this side to the 1/5. Now we need to go to our calculator to find that value. Okay, so we want to find our value of a. We need to use parentheses around our fraction, otherwise only part of it will be raised to the exponent. So we want 5 halves, and we want to raise that to, and use our fraction template, the 1/5. And if we hit enter, we get 1.2011. That's our value of a. Okay, so we just found that a, it's about 1.2011. So we'll use this. Now we get to pick whichever point you like. It's totally optional, whichever point you like. I'm going to pick the 0.32,000, and it's okay if you pick the other one. And we're going to plug into our exponential equation again. The y value is 2,000. I don't know y naught, but now I know that my a is 1.2011, and I'm going to raise this to the x is 3. Now I only have one missing variable, which is my y naught, so I can solve. Don't do yourselves a favor. Don't cube that number before you divide. Just divide by 1.2011 to the 3rd, because you don't want to get a huge decimal that you're going to be tempted to round, because you're not allowed to round until the end of the problem. So what we have here is that y naught is 2,000 over 1.2011 to the 3rd. Now we're going to go to our calculator and find that value. Now we want to find the value of y naught, or our initial value. So we use our fraction template. 2,000 over 1.2011 raised to the 3rd, and we have 1154.23. Okay, so we found that y naught is approximately 1154.23. Now we're ready to write our equation. So now we know that y equals y naught is 1154.23 times a is 1.2011 raised to the x. There we go. Let's try one more, and this time we'll use some simpler numbers. So again, we have a graph that does not have the y-intercept. So we're going to take both points, and again, I'm going to pick the point furthest to the right. So I'm taking the point 2, 12, and I'm going to plug that into y equals y naught, a to the x. So 12 goes in for y. I don't know my initial value. I don't know my growth factor, but my x is 2. Now I'm going to take the other point, 1, 6. My 6 goes in for y. I don't know the initial value. I don't know a, but my x is 1. Next, we divide the two equations. When we divide, 12 divided by 6 is 2. My initial values will cancel out, and a squared divided by a is just a. So now I have my value of a. It's 2. Next, we pick a point. I'm going to pick the point 1, 6, and you can pick either one you want. I'm going to pick 1, 6, and we're going to plug back into our exponential form. My y value is 6. I do not know my initial value, but now I know that my growth factor is 2, and my x value is 1. Now I want to solve for y naught, so in order to do that, I need to divide both sides by 2, and that will give me 3 equals my initial value. Now I'm ready for my equation. Y equals my initial value times my growth factor raised to the x. Okay, guys, hope this helped. See you in class.